everyone. Today we'll be continuing the questions of gradient and directional derivatives only. There were 6 to 7 questions more on this topic. So this is the 11th question. It is asked in 2015 civil services examination. So the question says that find the value of lambda and mu such that this surface and this surface may intersect orthogonally at this point. So what it says is the angle between these two surfaces given to us as 90 degree at this point. So we know that angle between any two surfaces is same as angle between angle between tangent at those two surfaces at some point. So we'll be using that only. So if we denote, let's say r vector, let's say denote the tangent for this S1 surface, so that will be equals to 2 lambda x minus lambda minus 2 I cap plus minus mu z j cap plus minus mu y k cap. Likewise, if I evaluate r2 vector, that is basically tangent at surface S2, so that will be 8xy I cap plus 4x square j cap plus 3z square k cap. Now if I evaluate these value of tangent at some surface, that is 1 minus 1 2, so it will be equals to 2 lambda minus 2 I cap plus minus 2 mu j cap plus mu k cap. Likewise, if we evaluate r2 vector at 1 minus 1 2, so it will be equals to minus 8 I cap plus 4 j cap plus 12 k cap. Now it is given to us that these two vectors intersect each other orthogonally. So that means that this theta is equals to 90 degree. Theta is 90 degree, and we know that angle between two surfaces is given by cos theta equals to r1 cap dot r2 cap divided by their absolute values. So here theta is 90 and cos 90 is 0. So we'll get 0 equals to r1 cap dot r2 cap divided by their absolute values. So if we evaluate it, so from here we'll get dot product of r1 vector and r2 vector as 0. So if we evaluate their dot product, so that will be equals to lambda minus 2 times minus 8 plus 4 times minus 2 mu plus 12 times mu equals to 0. So it simplifies to minus 8 lambda plus 16 minus 8 mu plus 12 mu equals to 0. So that can be further simplified as minus 8 lambda plus 16 plus 4 mu equals to 0. So from here I'll get eight lambda equals to 16 plus 4 mu, which is equals to 2 lambda equals to 4 plus mu. This is one relation. Now if you observe that given point also lies on the given surfaces, that is S1 and S2, so from there also we'll get some relation in mu and lambda. So if I plug in this point in surface S1, because only surface S1 contains constant lambda and mu, so that will give me lambda plus 2 mu equals to lambda plus 2. That simplifies to 2 mu equals to 2, and from here I'll get my mu is equals to 1. So mu is equals to 1, and if I plug in value of mu here, so I'll get 2 lambda equals to 4 plus 1. That basically gives me lambda equals to 5 by 2. So lambda is equals to 5 by 2 and mu is equals to 1, such that the given two surfaces intersect orthogonally at this point. So let's move on to discuss the next question. So the next question says that a curve in a space is defined by this vector. So a curve is defined by t square I cap plus 2t j cap minus t cube k cap, and we are supposed to determine angle between tangent to this curve at these 2 points. So we need to evaluate tangent to this given curve at t equals to 1 and at t equals to minus 1, and then we are supposed to find angle between those two. So let A is equals to tangent to this given curve at t equals to plus 1. So that will be equals to 2t I cap plus 2j cap minus 3t square k cap, and we need to evaluate it at t equals to 1. So this is equals to 2i cap plus 2j cap minus 3k cap. Likewise, let B denotes the vector to this given curve at t equals to minus 1. So it will be equals to 2t I cap plus 2j cap minus 3t square k cap. So at t equals to minus 1, it will be minus 2i cap plus 2j cap minus 3k cap. Now I need to evaluate angle between A and B, so that is cos theta dot product of A and B divided by their absolute values. So it will be equals to minus 4 plus 9 divided by square root of 4 plus 4 plus 9 times square root of 4 plus 9, which is equals to 9 divided by square root 17 times square root 17, which is equals to 9 divided by 17. So from here my theta, that is angle between tangent at t equals to 1 and minus 1, is cos inverse 9 by 17. So this is what they have asked. Let's move on to discuss the next question. So the next question is, it is asked in 2012 in forest service examination. So the question says that if u is equals to this, v is equals to this, and w is this, then prove that grad u, grad v and grad w are coplanar. So in order to prove that, first we need to evaluate what are grad u, grad v and grad w. So gradient u is equals to del u by del x I cap plus del u by del y j cap plus del u by del z k cap, which is equals to I cap plus j cap plus k cap. Likewise, we can calculate grad v, which is equals to del v by del x I cap plus del v by del y j cap plus del v by del z k cap, which simplifies to 2x I cap plus 2y j cap plus 2z k cap. Likewise, if I evaluate grad w, again that will be equals to del w by del x I cap plus del w by del y j cap plus del w by del z k cap, which simplifies to y plus z I cap plus x plus z j cap plus x plus y k cap. Now in order to show that it is coplanar, I need to show that this is equals to, the determinant of all this is equals to 0, sorry. So if I evaluate it, or let's just use certain certain row transformations, elementary row transformation, to simplify it first. So this is same as 1 0 0 2x y plus z 2 times y minus x 2 times z minus x, which is equals to x minus y, and here x minus z. Now I can pull out y minus x from the second column and z minus x from the third column. So it will be equals to y minus x times z minus x, which is 1 0 0 2 which is again equals to y minus x times z minus x. Or from here you can directly say that it will be equals to 0, because if you observe that column 2 and column 3 are same identical, so from here we can see that it is equals to 0. So this basically results that give us relation that grad u, grad v and grad w are coplanar. So let's move on to discuss the next question. So the next question is examine whether the are coplanar, where these are the features. So it is a repeated question, we just discussed it. So the next question says that find the direction derivative for f at point 2, 1 in direction of unit vector which makes angle pi by 3 with the x-axis. So first let's evaluate grad f, and then we'll find out the direction along which we need to evaluate the direction derivative. So grad f is equals to 2xy cube plus y I cap plus 3x square y square plus x j cap, and grad f at the given point 2, 1 will be equals to 4 plus 1 I cap plus 12 plus 2 j cap, which is equals to basically 5 I cap plus 14 j cap. Now we need to evaluate the direction along which we need to find the direction derivative. So we are supposed to evaluate it in direction of a unit vector which makes angle pi by 3 with x-axis. That is, if this is x-axis and this is y-axis, so this is the direction here where this angle theta is pi by 3. So here point will be basically r cos theta or r sin theta, but it says that it is a unit vector, so we'll choose our r as 1. So our vector a vector will be basically equals to cos theta I cap plus sin theta j cap, where theta is pi by 3, which is basically 60 degree. So cos 60 is 1 by 2 I cap plus sin 60 is square root 3 by 2 j cap. So if I find the direction derivative, so it will be equals to grad f times this direction, which basically gives me 5 by 2 plus 14 times square root 3 by 2, which simplifies to 5 plus 14 square root 3 by 2. So now let's move on to discuss the next question. So the next question says that find the direction derivative of v square, vector v square, where v vector is given to us as xy square I cap plus zy square j cap plus xz square k cap, and we are supposed to evaluate the direction derivative as at 2, 0, 3, and the direction is outward normal to this surface at this point. So first we need to evaluate this v square, because we are supposed to evaluate direction derivative of v square and they have given us v. So v square is basically dot product of v with v, which is x square y raised 4 plus z square y raised 4 plus x square z raised 4. Now gradient of basically v square is 2xy raised 4 plus 2xz raised 4 I cap plus 4x square y cube plus 4 y cube z square j cap plus 2z y raised 4 plus 4x square z cube k cap, and grad v square at this point, that is 2, 0, 3, will be equals to 4 times 3 cube 3 raised 4 I cap plus this 0 j cap plus 4 times 3 cube k cap, which is basically equals to 4 times 81, that is 324 I cap plus 0 j cap plus 432 k cap. Now this is gradient of v square. Now we need to evaluate the direction, which is basically outward normal to the given surface. So outward normal to x square plus y square plus z square minus 14 equals to 0 will be basically 2x I cap plus 2y j cap plus 2z k cap, and we are supposed to evaluate outward normal at 3, 2, 3, 2, 1. So let's name it as a vector. So a vector at 3, 2, 1 will be equals to 6 I cap plus 4 j cap plus 2 k cap, and the unit vector will be 6 I cap plus 4 j cap plus 2 k cap, which is basically divided by 36 plus 16 plus 4, that is 56, which is 6 I cap plus 4 j cap plus 2 k cap divided by square root of 56. So direction derivative will be equals to a dot product of grad v square with a cap, which is equals to 6 times 324 plus 432 times 2 divided by square root 56, which is equals to 2808 divided by square root 56. So this completes our question. So let's see what is our next question. So the next question is, find the direction derivative of this at this point along z-axis. Let's solve the first question. So let's name the given scalar as f, or let's name it as phi. So the phi is given to us as 4x z cube minus 3x square y square z square at 2, minus 1, 2. So grad phi will be equals to 4z cube minus 6x y square z square I cap plus 6x square y z square j cap plus 12x z square minus 6x square y square z k cap. So grad phi at 2, minus 1, 2 will be basically equals to 4 times 8 minus 6 times 8 I cube I cap minus 6 times 4 times minus 1, that makes it plus, times 4 j cap plus 12 times 8 minus 6 times 4 times 2 k cap, which simplifies to minus 16 I cap plus 96 j cap plus 48 k cap, and we are supposed to evaluate direction derivative along z-axis. So z-axis vector is given by 0 I cap plus 0 j cap plus 1 k cap. So direction derivative will be equals to grad phi dot product a cap, which is basically 48. Likewise, for the second part, let's name the given scalar as psi, which is x square yz plus 4xz square. So the direction they have given to us is 2 cap minus j cap, 2 cap minus j cap minus 2k cap. So unit direction will be 2 cap minus j cap minus 2k cap divided by square root of 4 plus 1 plus 4, which is 1 by 3 times 2 cap minus j cap minus 2k cap. So if we evaluate grad psi, that will be equals to 2xyz plus 4z square I cap plus x square z j cap plus x square y plus 8xz k cap. So grad psi at point 1 comma minus 2 comma 1 will be equals to minus 4 plus 4 cap plus 1 j cap plus minus 2 plus 8 k cap, which is basically 0 I cap plus j cap plus 6 k cap. So direction derivative will be equals to dot product of grad psi with b cap, which is basically 0 times 2 by 3 plus 1 times minus 1 by 3 plus 6 times minus 2 by 3, which simplifies to minus 1 by 3 minus 12 by 3, that is minus 13 by 3 is grad psi. So this basically completes our question on gradient and direction derivative. Tomorrow we'll see questions for divergence. Thank you for watching, and please do like, share and subscribe the channel. And if you have any comment, then please do that as well.